It is given that a truck blowing horn of frequency 500 Hz travels towards a vertical mountain and driver has an echo of frequency 600 Hz. If velocity of sound in air is 340, then the speed of truck is. So in a situation when there is a reflection from a surface, so for calculation purpose we can just consider this is car is nothing but an observer, because observer is sitting inside the car, and basically the horn of car is behaving like the source. So according to the observer, we can just assume that the reflecting surface is like a mirror, so he'll be able to observe his image. So which is the image of car, let's say that is taken as nothing but the source. So if the observer is moving towards the mirror with a velocity, let's say v, then the source is also moving towards the observer with a velocity v. Image velocity is equal to objective velocity. For easy calculation purpose, we can just assume like this. Then the apparent frequency, we can write this actual frequency into, as a source and observer are moving towards each other, we can write a c plus velocity of observer divided by c minus velocity of source. According to the question, it is given that the frequency heard by the observer is 600, which we can take it as the actual frequency 500, and the velocity of sound is 340 plus v divided by 340 minus v. So we can find out what about the value of v over here. So we can write this is equal to 6 into 340 minus 6v is equal to nothing but 5 into 340 plus 5v. So we can write this is equal to 340 is equal to nothing but 11v. So the value of v can be written as nothing but 340 divided by 11, which is equal to 30.9, which we can round off to 31 meter per second.